Today we're looking at Learn Target 2D, which is solving and graphing compound inequalities. The three things you should really be looking for in Cornell notes are the differences between and or inequalities, being able to solve the and or inequalities, and then being able to graph the and or inequalities. First, let's talk about the difference between and or. If we're looking at a Venn diagram, when you see the word and, it talks about what the two things have in common. So it's that intersection where both A and B are satisfied. With the or inequalities, it refers to anything that is in one or the other system. So in the case of a Venn diagram, it's everything that would occur. Let's see what that looks like in terms of inequalities. So first we're asked to graph x is less than 4 and x is greater than or equal to 2. So we're going to start just by graphing the x is less than 4 piece. Pretty easy, open circle at 4, shaded everything to the left. Second one, we're going to graph x is greater than or equal to 2. So we have a closed circle at 2 and we shade everything to the right. Since this is an and, we're going to combine the two graphs and we look at what they have in common, which is from 2 to 4. So your final graph should look like part D there, where you have a closed circle at 2, shade to the right, an open circle at 4, which ends the graph. Let's look at an OR example. We're going to start by graphing the x is less than 2, open circle at 2, shaded everything to the left. Graph x is greater than or equal to 4, so we have a closed circle at 4, shaded everything to the right. Since this is an OR, when we combine our graphs, it could be either situation, so our final graph should look like this. Go ahead and try to figure out which of these following inequalities, 1, 2, 3, or 4, represents the graph above. In this case, it is an AND situation, so you know it's going to be either 2 or 4. And so we've got to look at the circles. They're both open circles, which means that number 2 would be your correct answer. We've got y is greater than negative 3 and y is less than negative 1. Let's look at a compound inequality here. This is often how you see the compound inequalities written. Anytime you have that m in the middle, or your variable in the middle, between two numbers, that represents an AND situation. So we could write this as 6 is less than m and m is less than 8. We can then reverse the inequality on the right so that, the inequality on the left, so that we have m is greater than 6, since we seem to like having those variables in the front. And then we can graph that situation. It's everything between 6 and 8. Notice they're open circles because they are both less than when you look at the initial inequality up here, the compound inequality. So it's open circles, and we graph everything between 6 and 8. So we can read this as m is between 6 and 8. So looking at this compound inequality, how could we rewrite this? Since y is in the middle, we know it's an AND situation. We know that y is greater than negative 3 when we put the y in front. And we know that y is less than 5. So this would be answer number 2. Which of these compound inequalities would be equivalent to y is greater than negative 5 and x is less than or equal to 1? The correct answer here is number 1. Since the x is greater than negative 5, when we reverse it and put the x in the middle, the opening has to be going toward the x. And then in this case, the 1 has the opening toward it. So we end up with number 1 there. Let's look at now solving. In this case, the x's are not by themselves, so we have to first solve this compound inequality. So when we do that on the left side, we divide by 2, we get x is less than negative 3. For the piece on the right, we divide by 3 on each side, and we get that x is greater than or equal to 4. We will graph the two inequalities. And then since this is an and, when we combine the two graphs, we're looking for the intersection piece. Notice there's no place where it's shaded both blue and red. So in this case, there is no solution. There is no way that we could have x less than negative 3 and greater than or equal to 4. Let's look at the next one. So we again have a compound inequality. Since our variable's in the middle, we know it's an and situation. So we can break this into two problems. 3 is less than 2m minus 1, and 2m minus 1 is less than 9. Solve each one. So on the left, we would have 2 is less than m, and m is less than 5. When we graph that compound inequality, notice that the open circle at 2 and m is greater than that. Open circle at 5 and m is less than that. So we're looking at the shaded region from 2 to 5. Let's look at some OR graphs. In this case, we're looking at when x is less than 2, so we've got an open circle and shaded to the left, or where x is greater than or equal to 4, so a closed circle at 4, and shading everything to the right. Since it's an OR situation, it could be either one. Here's another OR situation. Go ahead and try to graph this. Notice in this case, we've got x is less than or equal to negative 1. So if I were to graph this, I would have an open circle here, shaded everything to the left. Or x is less than or equal to 3. Pardon me. Since x is greater than or equal to 1, I have an open circle and shade everything to the right. Since x is less than or equal to 3, I would have a closed circle at 3 and shade everything to the left. Since everything would end up being shaded, we end up shading the whole line.